Hi, this video will give you an introduction to the structures and formulas of the carboxylic acids. It will also cover the reactions of carboxylic acids with metals, metal carbonates, and it discusses what happens to carboxylic acids when they dissolve in water. The carboxylic acids are a family of weak acids which all contain the carboxyl functional group. Now the first member of this family or homologous series is methanoic acid. A ball and stick model, as well as a displayed and structural formula for this carboxylic acid are shown, and the carboxyl group is clearly highlighted. The next two members of the carboxylic acid homologous series are ethanoic acid and propanoic acid. Now in going from ethanoic acid, which contains 2 carbon atoms, to propanoic acid, which contains 3 carbon atoms, it is simply a matter of adding a CH2 group. And again, when we write the formula for these 2 carboxylic acids, the carboxyl functional group should be clearly shown. Now in GCSE chemistry, you're only required to know the structure of the first 4 carboxylic acids. The fourth member of the carboxylic acid homologous series is butanoic acid. The structure of butanoic acid and the general formula for carboxylic acids is shown. Now the general formula will allow you to work out the molecular formula for any member of the carboxylic acid homologous series. Before we look at the reactions of carboxylic acids, let's have a quick reminder of the difference between weak and strong acids. Now acids are aqueous solutions, that is water with dissolved substances in them, and in the case of acids, the dissolved substances are hydrogen ions. It is the presence of hydrogen ions in the aqueous solution which gives acids their characteristic properties. Now in the lab, the acid that you are most likely to use is hydrochloric acid. Now hydrochloric acid is a strong acid formed when molecules of hydrogen chloride gas dissolve in water. Now hydrogen chloride gas is very soluble in water, and when it dissolves, all the covalently bonded hydrogen chloride molecules will break up or dissociate to form hydrogen ions and chloride ions, which will result in the formation of a hydrochloric acid solution. This is shown in the word and symbolic equations on screen. Now the type of arrow used in these two equations tells us that hydrogen chloride molecules break up or dissociate completely to form hydrogen ions and chloride ions. The arrow indicates that the reaction goes to completion, that is, 100% of the hydrogen chloride molecules break up and dissolve to form hydrogen ions and chloride ions. This means that hydrochloric acid will be a strong acid with a low pH. In contrast, when the carboxylic acid ethanoic acid dissolves in water, very few of the ethanoic acid molecules will break up or dissociate. In fact, almost all the ethanoic acid molecules remain intact, and less than 1% of the ethanoic acid molecules will actually dissociate or break up. Now the arrow used in the two equations shown is the type of arrow that you would normally find in a reversible reaction. Now the ethanoic acid molecules which do break up form ethanoate ions and hydrogen ions, but the fact is very few of the ethanoic acid molecules actually break up, so this means there will be very few hydrogen ions present in an ethanoic acid solution, which means ethanoic acid will be a weak acid with a pH in the range of 3 to 5. There are a few ways to prepare carboxylic acids, but perhaps one of the simplest is to oxidize an alcohol using an oxidizing agent such as acidified potassium dichromate or acidified potassium permanganate. Now this oxidation reaction is usually carried out under reflux conditions as shown in the image. Here, the reaction mixture of oxidizing agent alcohol and sulfuric acid are placed in a pear-shaped flask and heated for around 20 minutes. Now the equations shown on screen show the oxidation of the alcohol ethanol to the carboxylic acid, ethanoic acid, using an oxidizing agent. Now the oxidizing agent is generally shown using the letters O inside square brackets. Similar reactions can of course be carried out using different alcohols such as methanol and propanol, which will be oxidized to the carboxylic acids, methanoic acid and propanoic acid. The reason that carboxylic acid molecules are acidic is simply due to the fact that the hydrogen atom attached to the carboxyl functional group is easily removed. This will lead to the formation of an acidic hydrogen ion and a carboxylate anion or ion. So for example, methanoic acid will form a methanoate anion and a hydrogen ion when it dissolves in water, while ethanoic acid will form an ethanoate anion and a hydrogen ion when it dissolves in water, while the third carboxylic acid, propanoic acid, will form a propanoate anion and a hydrogen ion when it dissolves in water. But recall that since the carboxylic acids are all weak acids, this will mean that the vast majority of the carboxylic acid molecules will stay intact and will not dissociate when these molecules are added to water. Carboxylic acids undergo the reactions of a typical weak acid. For example, they will react with metals to form a salt and release hydrogen gas. They react with metal carbonates to form salt water and carbon dioxide gas. They undergo typical neutralization reactions with alkalis and bases to form salts and water, and they will react with alcohols to form esters, but this is covered in a separate video. Let's start here by looking at metal-acid reactions. Now acids will react with metals to form a salt and release the flammable gas hydrogen. A strong acid such as hydrochloric acid will react quickly with magnesium ribbon to form the salt magnesium chloride and hydrogen gas. Now the reactions of a carboxylic acid with magnesium will be similar to those of a strong acid, but the action will be much slower since carboxylic acids are weak acids with a lower hydrogen ion concentration. For example, magnesium will react with ethanoic acid to form the salt magnesium ethanoate and hydrogen gas, while propanoic acid will react with magnesium to form magnesium propanoate and release hydrogen gas. Now if you need some help with working out formulas, then please click the links in the description below for a bit of help. Now metal carbonates will react with carboxylic acids to form a salt, water and the gas carbon dioxide. For example, the carboxylic acid ethanoic acid will react with sodium carbonate to form sodium ethanoate, water and release carbon dioxide gas, while the carboxylic acid propanoic acid will react with calcium carbonate to form calcium propanoate, water and carbon dioxide gas. Now you could test the gas released in these reactions by bubbling it through lime water to prove that it is indeed carbon dioxide gas. For more help and information on carboxylic acids and their reactions, why not visit the website that accompanies these videos? The links are in the description below. If you enjoyed this video, then please don't forget to like and subscribe. Thank you.